Seeing is believing, or so we thought. Let's take a blade of grass for example. This blade of grass is made of a series of atoms. Those, in turn, are made of electrons, neutrons, and protons. In 1964, scientists realized that these neutrons and protons are made of even smaller particles called quarks, which are held together by particles called gluons. Scientists think that these quarks could contain smaller vibrating strings of energy. Depending on the vibration of these strings, particles are given properties like mass and charge. Similar to how a guitar has different strings for different frequencies, instead of musical notes, these strings produce particles. These vibrating loops of energy can be open or closed. So what exactly led scientists to believe it was vibrating strings of energy instead of particles? According to Heisenberg's uncertainty principle, we can know either the position or the velocity of an extremely fast particle, but not both at once. Observing a small particle with an extremely high velocity can change the nature of the particle itself, except that doesn't happen when the particles are actually strings. Although particles made sense on paper, they didn't account for one very important force that exists: gravity. Scientists considered a particle called the graviton, which they believed was responsible for gravitational force. When gravity was introduced into their math, it fell apart. When you treat a particle as a one-dimensional strip instead of a single point, gravity could be accounted for. In fact, gravity proved to be essential to their math. Lastly, a whirl line is a path traced by an object in 4D space-time. In this graph, a point particle would trace a 1D line and a string would trace a 2D sheet. When a graviton is a particle, its interaction with another object's whirl line happens at a small vertex of infinite energy, resulting in a black hole. When it's a string, the vertex is large and the energy is spread out. This makes it stable, like it is in real life. So, thanks to Heisenberg, gravity, and whirl lines, string theory is the closest science has come to unifying the four forces of interaction that exist in our universe. Sounds perfect, doesn't it? Not so fast. This theory only checks out when there are not 4, not 5, but 10 dimensions in our universe. The universe we live in has 4 observable dimensions, 3 spatial dimensions, and 1 temporal dimension. Scientists have tried and failed to remove 6 out of these 10 dimensions and apply it to our universe. That's why we have no idea whether our matter consists of tiny strings or tiny particles. However, thanks to both the Standard Model and string theory, we are hurtling towards a future where a better understanding of our universe can help us make wormholes for interdimensional travel, engineer at the atomic level, and even simulate the Big Bang. With a unified field theory, we can unlock the secrets of our vast and ever-expanding universe.